Club is his baby. So from that, let's see here, he's going to be talking about integration for wind energy. We did give him a warm hand.
Thank you, Taylor. Thank you everybody for sticking here. I know you guys are really the energy lover because I've been late for 30 minutes. I really apologize for that. But hey, I'm doing something good for the club, okay? I'm trying to convince the rest of people to support the club, okay? So you have more pizza in the future. What I'm going to talk about today is some of the recent work that our group has been working on. I call it engineering clean, affordable, and reliable electric energy grid by use of smarter IT. Let me just do a quick survey here. How many of you are from the engineering school? Everybody. Who is not from engineering school? Which school are you from?
Environmental Studies, Geosciences.
Good. So that's actually the key message there. That is, when we talk about the energy future, I think a number of you were just there between 3 and 4, listening to the Vestas wind energy's presentation. As you can tell from there, there's a lot of push and pull in this domain right now. On one hand, you have the policy push, right? Because of the global warming, global climate change, because of the energy independence, energy security concerns. There is policy towards a more independent energy future and cleaner energy future. Right? On the other hand, if you talk to the grid, electric grid, where 2/3 of the energy was being delivered by, you have a lot of technical pull again. Why? Because they say, oh, the wind energy is not quite controllable. They are sometimes blowing, sometimes they don't blow, and typically they tend to blow when you don't want to use electricity. Then you say, oh, the solar power, sometimes the cloud comes, the cloud goes. You don't turn on and off the light following that, right? So you also have a lot of this grid pull. And some of you, or maybe all of you, must have heard about this quote, smart grid, one way or the other. The idea is that you want to improve the awareness of what's going on in the grid, and you want to better use the grid as the enabler of sustainable energy services. So you have a lot of technology push by the Cisco's and Qualcomm's and IBM's and the like. And on the other hand, when you stop and think about, what is the cost of deploying all these smart meters and what is the cost of installing all these sensors, does it pay off as a taxpayer? Right? You also get a lot of this sort of sustainability pool. Right? So the idea here is that what we are thinking about is that just as how we engineer the internet, or just as how we engineer the old power grid, we believe that there might be some middle way in which you may be able to align the incentives and objectives of different parties in this complex problem and try to make them compatible with each other by way of using smarter IT. And that covers much more integration of renewable resources. So perceivably it should be somehow cleaner. That also involves of more efficient use of the resources available out there. So I think, I hope that by the end of this talk, I'll be able to convey you that it's really worthwhile participating in organizations like this. Because only through organizations like this will you be able to break the boundary of your comfort intellectual home base and trying to understand the broader impact and the broader concern of this complex problem. Okay? So I think I've already enough, so let's continue. This is our team. I want to acknowledge the work that we have been doing. We're very blessed to have a very truly interdisciplinary team We work with electrical engineers, we work with economists, somebody here is from economist. We work with computer scientists, we work with statisticians, we also work with statisticians. I believe I also work with public policy makers as well. So that kind of conveys the way we do approach problem. That is, we really want to break intellectual barrier and then try to think about this problem based on the problem merit itself, right? So I will just kind of introduce what is the elephant in the room and talk about some of the open challenging research, / development questions, and just show you a sample of our research, which is more efficient scheduling by use of near-term, more accurate forecast. And I'll try to suggest some concluding remarks. So this is no longer a surprise to you. I think from various different sources you can find one way or the other fast-growing clean energy resources, right? Do you know which region has the highest installed wind capacity in the U.S.?
Texas.
Texas.
West.
West Texas, yes. That's exactly right. So not only we are the land of oil and gas, we are the land of wind and solar as well. So not only in Texas, China, India, U.S., Germany, Denmark, or even Africa. Omar is working something with Nigeria. There's some developing countries which is rapidly catching up, also trying to use more clean energy resources. Now, this is being pushed by a variety of reasons: energy independence, energy security, and environmental concerns. These are all legitimate concerns. But we want to have more of these clean resources. And this is about Texas, just to show you. ERCOT is the electrical power grid operator in the state of Texas. Its full name is the Electric Reliability Council of Texas. As of February this year, we have about 9.5 gigawatt of installed wind capacity. Now, a simple question. Do you know, on average, what is your house consumption of power capacity? In the summer day, let's say.
Couple hundred kilowatts?
A couple hundred kilowatts. Any other things?
Like 400, 500.
400? Yes, something on that scale, but maybe a little bit less. So you do the math, right? If you have 9,500 megawatt of wind installed capacity, how many houses can have power?
20,000.
20,000, right? 20,000 houses just from wind alone, right? So that's actually even more than that, because average house consumption is more.
It's like 20 million, right?
Not 20 million. Why 20 million?
Oh, because megawatt versus kilowatt?
But it's several hundred kilowatt,
Yeah.
not several kilowatt.
You get about 3 houses per megawatt, I guess.
Yeah, 3 houses per megawatt. So you say you have
A little longer.
10,000 megawatt. That's about 30,000 houses, right? So about 30,000 houses can be powered by wind alone. Now it's a dangerous statement here. Why? Because wind don't typically blow at its maximum, right? So what we're talking about here is the maximum installed capacity. But on average, in terms of energy, in terms of joules, in terms of kilowatt hours, it's about 8% of the overall energy that is being produced by Texas power plants. 8% of that comes from wind energy alone. Okay, 8%. So that is quite a yes.
But isn't 30,000 actually a really small number because there are 30 million in the United States? So
We're talking about Texas, by the way.
Texas
so-
only?
Only. This
Okay.
is Texas only. Yes. Yes, you're right. So it's still quite a small number. So the question is, what if we want to push for, I mean, the politicians are stating the goals of 2020. By 2020, you have about 20% of every renewable energy coming from either wind or solar or hydro, something like that, right? So you still have a long way to go. One thing for sure is that, one way or the other, this is going to happen, right? Now the question is, how do we make it happen so that you and me, as the regular taxpayers, don't have to spend too much tax or extra money for it, right? So that's the key question. And one perceived future, no matter how you think about that, let's just build a, you read President Obama's speech, you can say, let's build the intelligent, smart electric grid, and that's what's going to solve the problem. Let's just put, millions of smart meters. That's just going to solve the problem. Yes.
Is this supposed to be like are they like shooting for a nationwide grid, or is it more, is it
So-
gonna be regional?
In the U.S., there are 3 grids that is being synchronized. There is an eastern interconnection, and there is a western interconnection, and guess what? Texas. So Texas is electrically independent. Yes. So there is a, we can talk about the now of why they're interconnected, but the idea is that you want to have, better usage of many resources across the nation, right? Because where do people live? They live
It's
along the
development
coast.
and
Right, they live along the coast. They live in New York City, in California, but where are the coal basins? Where are the nuclear power plants? They don't locate there, right? So, anyway, so yes, the idea of the smart grid, you must have seen many commercials about smarter planet, smarter grid, and what have you on TVs these days. The idea is that let's just put sensors everywhere. Let's put the sensors in your house. We have the smart meters. Houston already is deploying 2 million smart meters of this year. I think College Station is going to deploying the same number of smart meters to your houses, I think by the end of next year. So these things are happening as we speak. Right? Now the question is, okay, it's just like you're going from X-ray to MRI, you know much better about the body, right? Then, so is that going to solve the problem? Meaning, if we know everything that is going on in the grid, and then we just continue how we run the grid, then that's okay, we can solve the problem. I want to pose the question here, maybe we can come back later. So the idea is that if we just overlay on top of the physical legacy power grid, another very extensive IT infrastructure, allowing you to know what's going on in real time in the system, is that going to just solve the problem, and then we will just be happy about it? You have the doctors take your MRI, but you still have some doctors to cure the problem, right? You cannot just take the MRI and then that's the end of the day. No, you still have to, do the operation. So I think maybe you need something more because, this is happening in Texas about 3 years ago. There is a sudden drop of wind forecast. There is a sudden drop of wind forecast in West Texas. The coal power plants were shut down for that day because they thought the wind is going to blow heavy. Coal power plants shut down. And then the cold front stopped. No wind at all. So what do? And then that's another holy grail of the energy problem, is that the primary source of energy, electricity, happens to be not able to store it in large amount. You can have milk storage or something, but you cannot have a big electricity storage, at least for now. Right? So the holy grail is that how do you actually make sure the supply and demand in almost instantaneous time steps has to be balanced. Now you have a shortage of wind supply because of sudden loss of wind cold front. What do? You start up, yes?
Can't you couple a natural gas plant to the wind plant,
Right.
and between the two of them, they produce a...
Right. You can do that. And happens to be that day, all the natural gas are already on. Still not enough. Nuclear is already on. Those several big coal power plants are turned off. So you say, just turn them back on, right? Okay. How much time does it take to turn on a coal power plant? 4 to 6 hours. Or 2 to 4 hours, depending on the size of the coal power plants. So you're facing basically 2 hours of shortage of power. And as I just said, the holy grail of the electricity problem is that you have to somehow maintain the supply and demand in balance in almost near real time. So what do? Well, you shut customers. You shut down the customers, right? You do the rolling blackout.